Greetings, I'm Nick Westerberg from Westerberg & Associates, and today we're going to be going over a Chalk Talk, one of many topics involved in the steaming world, and today we're going to talk about steam constants. So it's the numbers that we use inside of a boiler room to help calculate some of the different equipment efficiencies. The first thing we're going to take a peek at is 500. It is a number that we use, and it is derived from 60 minutes in an hour and 8.34 pounds per gallon. I'll show you how we use that in just a moment. The next number that we're going to look at is 34.5. If you don't know what the steaming rate of your boiler is, but you know what the actual horsepower rating of your boiler might be, you can take the horsepower rating of your boiler times 34.5 and it will give you an approximate steaming rate. The next thing that we can take a peek at is, once you know what that steam rate is, if you use that constant 500 and divide that steam rate by 500, it will give you an approximate evaporative liquid rate that the pump will have to provide to keep the water in that boiler to make that steam. The next thing we're going to take a peek at is another way to get the evaporative liquid rate, and that is to take the boiler horsepower times 0.069. And that will also give you an approximate evaporative liquid rate so you can evaluate your feed water pump. Once you know what the steam rate is and you divide that by 34.5, it'll give you the boiler horsepower if you need that. We can take one boiler horsepower, which is equal to 34.5 pounds per hour of steam at 212 degrees, and we can use that in our evaluations. We can take one boiler horsepower, which is equal to 33,475 BTUs per hour, 7.5 gallons per cubic foot. We use that once we know what the evaporative liquid rate is of the actual feed pump that we have feeding our boiler. We can take that pump rate, and let's say, for example, it's 80 gallons per minute. If it's 80 gallons per minute and I divide that by 7.5, when that pump is on and pumping, it leaves me with a 10.6 cubic foot space, envelope space, inside of that deaerator or feed water storage tank. My vacuum breaker that we size for feed water storage tanks or deaerators has to be able to break that at 1 inch of mercury vacuum. That's how we size vacuum breakers for those vessels. DA vent rate. How do we calculate DA vent rate? The DA vent rate is equal to 1/10 of 1% of the max steam rate of that boiler. So for example, if I'm steaming at 56,000 pounds per hour, 1% of that is 560 pounds per hour, 10% of that is 56 pounds per hour. That would be the vent rate for that deaerator or feed water storage tank if I'm steaming at 56,000 pounds per hour. And the last thing that I want to draw your attention to is the DA storage capacity number. That's how long of residence should that liquid be in the deaerator or the feed water storage tank, so that we can take the steam pad that we're going to put over the top of it to heat that water body up to an optimal 232 degrees or 7 pounds gauge, so that we can make sure and drive all the oxygen off. I want to thank you for coming today to one of our Chalk Talks. Please do me a favor and remember that it's all about the enthalpy in your system, and look forward to additional talks that will be coming to you in the near future. Thank you.